So what we'll look at today is a little bit of nomenclature, or look at in the next 20 minutes. Least favorite subject, and I would kind of lean towards, I think, abolishing all of nomenclature as something that students should really be studying. And it's a bit of an overstatement, but what we're looking at is how do we name individual structures. And the reason we need to be able to name structures is so that we can communicate that knowledge to somebody else. Well, with the advances of technology, we can draw structures. We don't need to name them. We can draw them out. Once they're drawn out, we can then show other people those structures and we can have that conversation. We're still probably a bit distant from that kind of future, but I think that should be coming eventually. That said, you're responsible for nomenclature. Again, it's my least favorite section of all of OChem. It is currently kind of important, so you do need to have some kind of basic understanding for nomenclature. That is what I think this slide does. So this slide pretty much summarizes all of nomenclature and puts it in one place, and this really covers 60 to 70%. As I scan through it, make sure, yeah, about 60 to 70% of what you would need for naming any individual compound, particularly in a multiple choice scenario. For those of you that haven't had OChem with me in the past, you will see nomenclature as a multiple choice because there's so many different places where things could be slightly askew that if we graded it nitpickingly accurately, a single question could be graded down into the tenths of points for how many different places you could make mistakes. So take that however you want to. Make sure you understand everything about this. So we'll real quickly walk through some of those points. So first and foremost, we do need to know our prefixes and what they mean: meth, eth, pro, but, pent, hex, hept, oct, non, and dec, representing the number of carbons in the longest carbon chain that contains the highest priority functional group. And that highest priority functional group is a really important aspect because you can end up with a really long carbon chain that doesn't contain a high priority functional group, and now you run into this dilemma of which way do you name it. Okay, so you have to name based off of the highest priority. What is the priority of those functional groups? Well, the priority of those functional groups is now listed in that kind of red box where acids are our highest, and it kind of works our way down. There are some kind of gray areas. For instance, these two are roughly equivalent as far as nomenclature, and really alkanes, all three of those are roughly the same priority level, which means we'd have to move to other systems. So that other system, hopefully you remember from first semester, would be an alphabetic system. So in cases of ties, you'd go based off of alphabetic. Meth or F comes before meth. Chloro becomes before ethyl, based off of the alphabet. You will notice that there are some things that are kind of bolded in some cases. So in our prefixes, you'll note that I've got 1 through 6 bolded because those are absolutely going to show up with insane frequency. I don't think you can encounter a single question that doesn't ask some level of that, which means those have to be memorized if you're going to pass the class. For the hept, oct, non, dec, those show up less frequently, so I would argue you don't have to memorize those, but having some familiarity with them can help. When we look at the priority of naming, you'll notice that there is some bolding within that. That bolding is really an artifact of calling out when we talk about particular functional groups. So this is a copy of the nomenclature slide when I was talking about alkenes, alkynes, alkanes, and halides, which is why those are bolded. But really, you're responsible for all of those. This slide will pop up periodically throughout the semester when we talk about those functional groups. So right now, what should have been bolded were our aldehydes and our ketones. That would be a lie. I'm thinking too far ahead. Should be kind of our alcohols and under. All of those should really be bolded because those are the functional groups we're really kind of addressing. Okay. Branch structures. If you've got a branch, we usually name it as a substituent. We know it's a substituent because we have the YL ending on it. You always have to provide a locator identification, and that's based off of the number in your carbon chain. You've got your halogens listed out with their prefixes, and then we've got kind of our rules listed at the bottom. Longest carbon chain has to have the highest priority functional group, and then you may need to assign your appropriate prefix for the number of carbons within it, and then the suffix is going to be dependent on what was your highest priority functional group. So if we went through and looked at a quick example, this structure would have the -ene suffix because what we've got in this is an alkene. So there's 3 carbons, so we'd call it prop, there's our prefix, and then -ene. If we want to get super specific, we'd have to call it 1-propene because we start with the lowest number. That specificity is something that IUPAC has been pushing because IUPAC as a conglomerate wants to be extra specific in the naming system. However, it's very hard to get the overwhelming population of chemists to absolutely agree with that. And so a lot of people will just use propene. So when we talk about nomenclature as there being one rule set, there isn't one rule set. There's tons of rules, and you can use different names for the same compounds. You have to be a little bit careful on it. What I did want to address before I got out of that would be if we made this a little bit longer, say a butene, and we now added an OH on this. Okay, well, this is going to change kind of our basic components within it. And what I should be having in here is parentheses. Okay, and why that parentheses? Well, as we go up in higher priority functional groups, the E part of our ene, ine, or ane changes. Right? Because we have a higher priority functional group, we have to address that higher priority functional group, right, as a suffix. What happens if we continue this structure out and we say now have 2 high priority functional groups? Well, now this aldehyde takes precedence over the alcohol, so we have an alternate way to name those kind of higher priority functional groups when they aren't the highest. And that's what's in the parenthetical. Those end up coming in as attachments in the front. Okay. So lots of rules. Again, this gets you the basic kind of patterns behind it, and that's really what I want you to get out of it. Okay. Of course, that's not all of it because we also encounter stereochemistry, and we would have to specify that stereochemistry in the name as well. The rules from those come from the Cahn-Ingold Prelog rules, and this is where we would encounter for alkenes the EZ nomenclature system, the cis or the trans cis, if we want to get that kind of respectively. The trans cis nomenclature system isn't a nomenclature system. It's a way of describing relative arrangements. So trans and cis are not IUPAC, E and Z are. If we have chiral atoms, those need to be labeled as R and S. You do have the potential of saying plus minus appear, lowercase d, lowercase l, or capital D, capital L. All of those systems all apply to the same concept of a chiral center, but how you determine whether it's capital R, capital S, plus minus D, L, capital D, capital L is all different. So make sure that you know what the system is when you go through and apply it. The RS system is the one that we will use, and that is based off of a structural determination. Okay, what do I mean by that? We look at a drawing of a structure, and we would then have to go through and identify the arrangement according to these rule sets. The plus minus would say, I don't actually have a structure, I have a sample, and when that sample hits light, light does something. That's the plus minus system and the lowercase d, l. So this is kind of experimental. And then the capital D, capital L is largely used with Fischer projections and carbohydrates. So why shift? Well, it's easier to deal with it in different systems. So when you're looking at carbohydrates, the DL is an easy way to differentiate different types of sugars, and that's why we would use it there. So each of these kind of naming systems has different priorities. Be aware of that. When we're looking at our Cahn-Ingold Prelog rules, the Cahn-Ingold apply to E, Z, R, and S. Everything else is a different rule set. So this is our system behind it. Because we're looking at structures, you have to make sure your structure is drawn correctly to be able to do a valid interpretation. With pi bonds, we have to acknowledge that those carbons are sp2 hybridized, which means they are trigonal planar. And because they are trigonal planar, we have a bond angle of 120 degrees, which means we're trying to show that as 120 degrees. If you drew out your structure something like this as your double bonds, well, that now becomes difficult to interpret. And ultimately, for a computer system that's trying to grade you, like our online homework, it has no idea what you're trying to do and will mark you as incorrect. So when you draw your structure, make sure you draw it as accurate as humanly possible, okay, to the three-dimensional reality. Right? If we go to a chiral atom, the chiral atom has a carbon with 4 different things connected to it, and we get the wedges and the dashes and all that fun stuff. Okay, again, we have to make sure we draw it correctly. Drawing it in this fashion is incorrect. And why is it incorrect? We'll build a model and try to orient the model in such a way that that drawing becomes valid. And you'll find it is literally impossible. You can't do it. Right? If you can't build the model to do it, then don't draw it that way. Right? So make sure you're drawing things correctly. A quick check, your wedge and your dash should make a V pointing to the V of your solid lines. Okay? Note they're kind of inverted. So if you just go through and draw 2 V's, and then you could put a wedge and a dash, note the V is a different V, but that's valid. There's still a V shape there. It's just aimed the other direction. Okay? But those are our rules. Again, what you've got is kind of a quick summary on just how to draw those or represent those. Which then gets us to our advanced naming practice. So we've real quickly summarized those rules. So what I would like you to go through and do is pause the video and attempt these. And because I trust you so little, sorry, that's what happens in an online environment, you're actually going to get a question on the very first one right now. So hopefully you were able to get that figured out. If you weren't, then you should talk to me about it. That was actually a really mean one to do because that's a pretty complicated structure. But you can talk to me, send me email, that kind of conversation to figure out that you're getting all of the individual pieces behind that. What we will go through and do is the other one. Right, we'll pick some of the easier ones because, of course, I don't want to solve the hard ones because I'm a jerk. 1, 2, 3, 4, 5, 6. I'm going to number it that way as opposed to 1, 2, 3, 4, 5, 6, because in the priorities, the aldehyde functional group, the aldehyde being right out here, is the highest priority, which means it needs the lowest numbers, which means the blue numbers don't work for us. Okay? And then our other functional group, whoops, let's color that something different. We've got the ketone there. So as our prefix, we're looking at 6, which would be a hex. If we look at the hybridization through the backbone, it's all really sp3 connected carbons, which means we're getting an ane backbone. This then ends with the aldehyde, so that suffix is al, so I'd get a hexanal. Officially, I should be trying to throw that 1 in front, but again, because it's an aldehyde, I know those are either the beginning or the end of the chain, so I don't have to specify the number. If there's only one, then it has to be at position 1. To get in the ketone, I can't bring in the -one ending because -one as a suffix would overlap with the aldehyde. This is where the secondary name comes in, and the secondary name for a ketone is oxo. So we're looking at an oxo on this. That oxo shows up at position 4. So the name I would get here would be 4-oxo-1-hexanal, and there's the name. Okay, so relatively straightforward. Notice we get dashes anywhere we have a number letter sequence, and we don't have any spaces in this, so there's no spaces. Okay, that spaces thing becomes a tricky one when trying to type things into an online homework system, which is why I don't ask that on online homework and you just get multiple choice. Okay. So again, I'm going to ask you to go ahead and pause and try that name to formula or name to structure. And I'm going to assume again that you've already gone through and done that. So let's go through and take a look at that bottom one. How I would go through and do this is look, okay, for that hex, because that's getting me my primary structure. I don't see a term cyclo, so I need to be going 6 carbons, 1, 2, 3, 4, 5, 6. And I could draw the numbers down in attempt that, let's assume this was a multiple choice. To that end, if we assume it was a multiple choice, most people are going to number this drawing as 1 to 6, left to right, which means most people are going to accidentally stumble upon the answer. So if you want to kind of think through what a potential multiple choice test is going to do, they're probably going to number it the other direction in what they represent as the answer. Right? Don't overthink this too much, because this could very easily turn into a you know what I know, that you know that I know that you know how to number it right, and it can become confusing. Right? But if you're just trying to draw it out, that's probably the easiest bet. Okay, to that end, after I've done the hex, I'm going to go to the right, okay, because to the left is all substituents, okay, and I want to identify what my core functional aspects are. When I go through and do that, I see this 2, so I know at position 2 something's going to be happening. Okay, what's going to be happening at that position 2? Well, what immediately comes after that is that ene. Okay, so what I'm saying is at position 2, I have a pi bond. So there's a double bond. Okay, this is where it gets a little bit weird, and I don't know if you heard it, there was a slight pause when I was looking at this. Because we get the ene, and then we get the oic acid. Okay, well, what's going on with that oic acid? Where should that be located? I don't have a number identifier here. So does that mean at position 2, I should have a carboxylic acid? Well, if I did that, then that doesn't show the numbering right. Okay? So what's going on with that? Well, what's going on with that is the exact reason why IUPAC went through and said, you have to specify the number for every single thing, which means really what I should be seeing is 2-ene-1 oic acid. Remember, the carboxylic acid is the highest priority functional group, which means it has to be at position 1 in this case. So there's the oic acid. If we add that 1 in there, it makes the name look more complicated, but it's more clear when we go through to do the building the structure. If we now go through and look at our substituents, at position 4, we have an oxo. Well, the oxo is a carbonyl. And then at position 6, see if I'm running out of colors here. At position 6, we have a hydroxy. And what we've now put together is the whole name. What wasn't specified in this name was the Cahn-Ingold E or Z. Right? If it's not specified in the name, do whatever's easiest for you and realize that your answer choices may have those flipped around. Okay? It may be given as E, it may be given as Z. officially we should be specifying that because this structure does exhibit cis-trans isomerism because we have two different things. Okay. With that, we've covered our basics for nomenclature. Hopefully that was useful for you, and we will go ahead and stop this video, assuming I can get out of it.